Good afternoon. So my name's Will Munns, and this is one of my circuit boards. This is the RoboCon PiLow cover board. And what we're going to do now is we're going to look through how we go around soldering one of these boards up for use in the RoboCon competition. So we're going to be interested only in what's on this side because it's a single-sided board. And we just flip this around. On this board, we've got a bunch of LEDs here for user outputs, um, two big motor controllers, some smoothing capacitors and control stuff, and then these final devices. These are shift registers. This is a bunch of NAND gate logic, and this is a transistor pack for driving the LEDs. The only thing that's on this board which is really critical that we don't make a mess of is this long connector here. Everything else can be pretty much heated up and jogged about, but if we mess up this component, this connector, then it will be a real pain to try and straighten that up. So we're going to have to take particular care about that when we solder it. So before we can go anywhere with soldering, we have to start by putting solder on the board. We do that using a stencil. A stencil is exactly like it is in printing t-shirts. It's just a big board with holes in it. And the idea is that we stick our stencil on top of our circuit board, so our circuit board sort of slides underneath, and the stencil lets through enough solder in the form of a paste that covers all of the pads and nothing more, so that when we heat it up, all the solder wants to stick onto the pads and there's not so much solder around on the board that it shorts out the connectors. So if you'll bear with me for a second, I will just open that up. So here we have the circuit boards again. You can see here I've captured it by taping down a bunch of old circuit boards which have errors on them. In your case, you should have this sunk into a piece of wood which keeps it captive. And then we fold down over the top the stencil, and in your case this should be almost perfectly aligned already. In my case, I'm a little bit out, but there's not a lot I can do to jog it back. It's probably close enough for my purposes. Certainly for this side, we've only got these little resistor arrays which are tiny. Everything else should be okay. I apologize for the lighting. This is absolutely the worst thing in the world to be trying to video because everything is shiny. So what I'm going to do now is I'm going to get some of this, which is solder paste. You may well have this in a syringe form. And I'm going to get a daub of this and stick it on the board. So let's get my daubing device, which in this case I'm going to use some tweezers. Now, um, what we're going to do is we're going to essentially squeegee this down into the holes. Now this is something which is going to be messy, but also something which you want to really avoid getting inside your body. So once you've done this, do not eat anything until you have definitely washed your hands. So as soon as you finish doing this messing about with solder paste, I advise you to go wash your hands at that point then and there, because otherwise you're going to forget, stick your fingers in your mouth or do something like that, and you don't really want to get this stuff inside you. It's not good for you. So we take it and we take some sort of scraping device. Look, I've got loads of these little boards. I wonder what they're for. Not that one though. This one is better because that one is a valid board and this one is a dead one. So we will squeeze this down and you can see I've messed up because up here you can see there are voids where the solder paste hasn't gone all the way through, and down here there are a couple of voids. That basically means that I haven't used enough solder paste, but I'm going to give it another sweep with the same lot and sweep it in some other directions. No, I need more solder paste, so let's go get a bit more from the pot. Now, as long as I'm putting a decent amount of downwards force, this should be fine. You might find that you squeegee it out and it ends up going all over your circuit board. In that case, wipe it all up with IPA and give it another go, because you don't want too much solder paste on the board. So here we go, let's have another go. Perhaps I should use something which is a better scraper than this, maybe a loyalty card or something like that. But here we go. Right, so we've got, I believe, a nice covering of paste down all of the holes, and I've dribbled some across the middle of the circuit board there, so let's squeegee that up. Okay, right, I'm going to get as much as that as I can back in the jar, because otherwise we're going to burn through it like nothing else. So we've got that now. If we lift this up, oops, lift this up, we should end up with a nice circuit board. And as you can see now, if you look at that, there's lots of bubbly grey stuff all over the pads, and each of the pads are nicely separated from each other. So we can do a quick visual inspection here and say, yeah, this looks good. There's solder paste everywhere that we expect it to be, and nowhere that we don't expect it to be. So I'm going to take that as an acceptable board. There we go. So put that aside. So the next thing to do is find components to fill this board. Now each of the components on the board, I flip it the right way around so it's easier to read. Each of the components on the board is marked with what it is. So here you can see this is a 74 HC595. That's a shift register. So there's two of those, and we should find a package with a 74 HC595 in the drawer. You'll also notice there's a 0.1U. These are capacitors 1, 2, 3, 4, 5, 6, 7, 8. These are really common. We use them near components to smooth out their power supplies, because otherwise, as this 74HC595 is clocked, all of the logic all jumps up and down at the same time, and that puts noise out on the power pin, and that noise can spread across the circuit board and cause unwanted things to happen in other places. So every device that uses power ends up with one of these 0.1U capacitors on it. You'll see on the other boards that we make up that we've also got some 10U capacitors. They do the same but for bigger spikes, and here we've got two 180Us. In fact, I think the ones that come in your packet are 200Us, and those are bulk capacitors. So they're when the motor controllers are switching large currents, these are absorbing the big ripple that is caused by these things switching on and off massive currents in order to run the motors. So we are going to now go over to our parts drawer and pick out some components, and then we're going to go place them. Okay, so here we are back at the desk, and you can see now we found ourselves a bunch of components. And the really eagle-eyed amongst you will notice that I'm missing three. They're these 1, 2, 3 LEDs at this point, and that's because they are blue, red, and green LEDs, but actually they look exactly the same. So we don't want to take those ones out of the packet until we're absolutely certain that they're going to go straight on the board. So leave those ones in the packet, but go and collect all of the other devices which are going to go on the board before you get to this step. Now, one more word of warning: there are a bunch of static sensitive devices here, and you probably are wearing something that's going to be building up static on your body. So before you get to this point, while you're getting the components out, and before you take anything out of any of these plastic packages, I want you to touch something which is grounded. So if you've got, say, a soldering station near you and it's got an exposed bit of metal and it's plugged in, feel free to give that a touch. If you're short of anything which is plugged in, if you can find yourself a plug socket, if you touch the screw on a plug socket, that's always connected to the earth, so that will sort you out. Just give that a touch with your finger. Hopefully you shouldn't get a nasty shock. If you do, you can complain to the people who fitted the socket. And so once that's done, we can move on to placing these devices. So I'm going to start with these little capacitors, because some of these devices sit up high off the board, and if they sit up high off the board, they're going to make it a pain to get those capacitors into place. So I start with that. Now, my tool of choice here is a pair of tweezers that is suitably relaxed when you let go of it, that you should be able to pick up, you have a look here, the whole of one of these devices without it causing a problem. If you have to pry your tweezers apart, it's going to be a real pain to let go of things when you get it down to the circuit board. So take these sharp tweezers, and we're going to grab this little hook here, this little bit of plastic, and we're going to peel it back. And it's going to be a pain because I'm on camera. Here we go. Right. So I know. I'm going to take all of these. I'm just going to tip them out carefully on the desk. Now, be careful with these. They do disappear. And I have put in exactly however many you need to do the circuit boards that you've got. They're not terribly expensive components, but they are a pain if they end up in a carpet. So I'm going to put these down. I'll pop it down on the board and just give it a little press, and that'll seat it down into the solder. Don't worry if it's slightly misaligned. We'll see that magically jump into place when you come to heat it up later. But do try to make sure that it's pushed down, because if it's not pushed down onto the circuit board, it'll lift up in a process we called tombstoning, where it will lift up fittingly around Halloween, a bit like a tombstone, jump off the circuit board. And it's not the terrible end of the world, because you can always push it back down so it sits on the circuit board again, but it's just a bit of a pain when you get around to soldering. So just push them down, and they should hopefully make sure it doesn't do that. Now, for the sake of the camera, I'm not moving this circuit board, but feel free to move the circuit board into whatever orientation you find fits best for getting these things down. There's lots of different ways that you can move things around. Don't be constrained by the way that things lie on the table. You can always move it or move you to get yourself a better position. And obviously, if you're left or right-handed, that may change the way that you put things down. Don't let anybody else tell you where you need to stand. If you don't feel comfortable while doing this, just move yourself around till you are. Now, I don't know if this comes across on camera. These pads, they're touching each other. A little bit of extra solder has got through, and it's touching all the pads. That's going to get worse when I place a component on there, but don't worry about that, because as I say, these pads have only just got enough solder on them so that the solder will wick onto the legs of the devices. So that will tend to break up on these devices, because the legs are, although they look quite close, they're a reasonably long way away from each other. You'll see later on when we do the second circuit board that there are some devices which are a bit more of a pain than that. Okay, so we're going to go now onto these components. These are, now I apologize, I'm going to have to look very carefully at these. In order to get the light right for this camera, I have the lights on in the room very, very slightly. So this is an HC00M. You can see it on the second line here. I'm not sure you can see that. Let me see if I give it more light. No, that's terrible. I'm going to go back to where we were before. But these are the logic. So again, I'm going to tip these out on the desk. Now, on these devices, we are going to try blinding. Right, you can see it's got a stripe at this end. Now, a stripe is indicative of where pin 1 is. If we don't look down on the circuit board, you can see I've put these little arrows down on the circuit board. Those are indicative of where pin 1 is. Now, if I pick this up like this, it's going to be a pain to put it down because it's the wrong way around on the circuit board. And I could struggle my arms around, or I could just move the circuit board. So like I said before, just get it where it's easy for you to use. I just drop that down onto the board, plonk, like that, give it a little nudge, and now it's in place. Now let's see the next one. Turn it over. There it is. It's the right way around for the board as it's currently lined up. Drop that into place. Give it a little nudge. Okay. We want it to be as best aligned as we can be. Although, as you'll see later on, for some devices, that doesn't matter too much. It will grab it and put it back into place. Now, this one is the 74HC595. And in this case, this device does not have pin 1 labeled. So, if we look at the device itself, you'll see that it's got a chamfer on it. It's a bit difficult to see. This front edge, this front edge of the device has a little, oops, no, this is going to be too terrible for you to see. But if you were to look at it in profile, what you'd see is this shape that's down on the circuit board here. And I've popped that on the circuit board to make it easy for you to work out which way round it is. So the chamfer is on the side. Whoop. The chamfer is on the side that has pin 1 on. So in this case, it's this way round. I'm going to drop that into here. I'm going to give it a little nudge just to get it in the right place. And that little nudge has moved around the solder, but we're not going to worry too much about that because, as I say, heating it up and the solder is going to move back to where it was before. Pick this one up the other way around. So onto the circuit board it goes this way. Push it down and we're all good. So those are those devices left. So now we've just got the ULN 2003. Now this device is a bunch of transistors in a single package, and are usually used for driving LEDs. And this one is more obvious. The chamfer is more obvious what side it's on. I'm going to drop it into place here. Okay, there we go. So next up is this device. Now this, I'm going to go back to spraying on the wall. Right, this device here is a TVS diode. And TVS diode is a transient voltage suppression diode. It is a type of diode used for grabbing negative voltage spikes. We put it here, and you can see it's got a line on this end, and it points into this cup on the circuit board. The line on this end indicates that it will conduct in this direction, right, from negative to positive, which in normal use this board would not do, because this area over here is the ground and this area over here is the battery voltage. So this will only conduct in normal terms if the voltage reverses. Now that seems like it's not a very likely thing to happen because there's a battery in this system, but if you're running DC motors and then you disconnect the power, the DC motors will act as a generator. So you can be in a situation where you're driving the motors forwards and backwards, and these big motor controllers will dump that power into the voltage rails, and that diode there short circuits things so that that negative voltage doesn't end up on the main board and cook everything. Okay, so next we have these. These are capacitors. As I say, these are bulk capacitors. Their job is to handle the high current demands of the motor controller. And if you look, their base has a particular shape. It's got some square corners and some knocked off corners, and they match down here on the circuit board. And if you look at the circuit board, you can see there's also a little plus, and there's a stripe. The stripe is always negative, and these capacitors go back to back. So here we go. Squeeze that one down. Okay, So those ones are the things that they're going to move around if we're not careful about it. Most of the other devices are going to sit nice and carefully on the board, and if we jog the board around, it won't matter too much. But these ones are big and heavy, so we just got to be a bit careful with how those are lined up when they get as far as the hot air station. Everything else should be okay. So now I'm going to move on and do these. These little 8-pin devices, they are resistors. If you're thinking a resistor only has 2 pins, that's because these are resistor arrays. So there's 4 resistors in each of these packets, and they are super tiny. But they mean that we don't have to do loads and loads of soldering of individual resistors. So I'm going to jog this over here. Now this, on the top board, these devices are the devices which have the smallest legs and therefore the ones which are most likely to actually go wrong. So I would start with this circuit board and work your way down onto the other circuit board, because using these components will get you used to what it's like to use the smaller components later on. So, and of course, if you mess these ones up, being just resistors, they're quite happy to be reworked with a soldering iron without causing any issues to them, whereas some of the other devices can be a bit more sensitive of that sort of thing. So now onto these resistors. These ones are 2 resistors in a packet. There's a red resistor. Yes, again, don't flip them over the desk. There's a red resistor. Sorry, there's a red LED and a green LED in a single package. And that's why they've got 4 legs. And they sit through this little hole in the board. So if we look at the back, oops, you will do a lot of dropping of these devices. It's inevitable. Just keep track of them. Okay, so if you look at the back of the device, my tweezers are very slightly magnetic, which is sometimes useful for picking things up and sometimes terrible because you can't let them go. But you see this got a stripe on them. This stripe lines up with this stripe out here, so you can tell which way around these go, because if you fit them the wrong way around, they won't light up, and then there will be sadness. We don't like sadness, so let's get these on the board. Again, these devices, they're very fiddly to get to the right place. Once they're in that hole, they're fairly easy to jog about. And from this angle, it looks like the solder paste is in the wrong place, but we'll see how that looks when we stick it on the hot air station. Oops. So when it gets to this fiddly stage, I'd recommend that as well as a pair of tweezers, you hold in your other hand a really sharp knife, like a scalpel, because it's very useful to be able to direct things around using a scalpel. And the main reason I haven't got one here is because there really isn't space under this camera, but I suggest that you have one. Okay, so we've got our 3 bicolor LEDs in place. We're missing our red, green, blue ones, and so far we haven't fitted these big motor controllers. So onto the motor controllers we go. Now, the motor controllers are enormous devices, and they're very heavy, and they have a huge amount of thermal mass. Now you'll see this one has a tiny dot and a chamfered off corner. The chamfered off corner indicates that it's pin 1, so that goes up here. So we're going to take this, and we're going to carefully drop it into place here. Now the thing about the motor controllers is that they in order to deal with the high currents that they can deal with, they have to generate a lot of heat, or they can generate a lot of heat. Depends on the size of the motors you're using. And in order to get rid of that heat, there's a big thermal pad here in the middle, and it's very important that that pad gets soldered. And it's the main reason that you're using, on this board, you're using a hot air rework station to solder them, because it's very difficult to solder a thermal pad. Its actual job, obviously, is to take the heat away. So naturally, it causes problem soldering. But also it's trapped underneath the device, so it's very difficult to get to. So that's these two components fitted the right way around. You can see the dots. These are fitted the right way around. You can see the stripes. This is the right way around. You can see the chamfer. These ones are the right way around. You can see the chamfer. So we've got two more, well, four more things to go. One is this connector. So this connector, oops, I'm going to recenter you. This connector goes down here. Now, it's important that this connector ends up in the right place, because if this connector doesn't end up in the right place, then when you go to plug the boards together, they won't go together, or at least they will go together, but then they won't fit in the frame that holds all the robot components together. And I'm not fantastically convinced about the amount of solder that's on here, and maybe we'll see later that I was right or wrong about that, and we'll have to come back and solder it with a soldering iron, but that's fine because it's a connector, and connectors are quite happy to be resoldered again and again, as long as you don't overheat them. So now we go on to the LEDs. These ones are the green ones, so I'm going to take one green one, and the green one is obviously, according to the silk screen, it's at the very top. So let's snip one of those out. One green LED. Put it back in the packet because I do not want to mix these up. If you do mix them up, then as long as you don't put them on the circuit board first, you can use a multimeter in its diode test function. And the diode test function puts just enough current through the LED to light it up, although it will light it up pretty dimly for most LEDs, but you should just about be able to see whether it's lit up by the multimeter, and that will give you an idea what color it is. But it also quite useful for working out which leg is which if you forget that the long leg is the negative. Of course, there isn't a long leg in surface mount devices, but there's a convenient arrow, and this convenient arrow is the same as the arrow next to it, so that should make it easy. So we've done the green, so let's look for the red. There's the red, green, and here we go. Here are the red ones. Let's take one of the red ones. Snippety snip. Let's go. Oh, I appear to have knocked off that connector. I don't know when I did that. I'll have to go back and fix that in a second. Maybe you should put the connector on last. Okay, so this is the red one. Rotate it, and it's the right way around. Drop it into the hole. Give it a squidge. Okay, and then finally we're looking for the blue one. Blue ones are here. You can see that I've taken one LED off the end of each one of these rolls in the past, which tells you how many boards I've made up from this packet. So here are the blue ones. Turn it around. Drop it back into place. Now obviously I've gone and put everything back in the packet as I've gone along, so I shouldn't lose which LED is which. And now I go back and revisit this connector. Okay, so at this point, it's worth doing one more visual inspection. Our capacitors are the right way round, our diodes the right way round, our ICs are all the right way round, and our LEDs are all the right way round. And finally, you might want to just check on things that really matter on their positioning. Right, so the next thing to do is fire up the hot air station. Now we're going to do two things here. First is we're going to switch on the heat plate because we need to make everything as hot as possible before we even start warming things up. Before we start hitting it with a hot air gun. So I'm going to switch on the heat plate. I'm going to switch on the soldering iron because we're probably going to need the soldering iron in a few minutes, and I'm going to get everything warmed up. Okay, so 1 second. Okay, so over here we are now on the heat plate. This has been sat on the heat plate for a while. The plate itself is set to about 280 degrees C, and you might just be able to see some wisps of solder paste venting off. The solder hot air gun is also here. I haven't kicked that up yet. Now what we're going to see is the sort of dark grey solder from before is going to sort of cook off into a sort of into a lighter grey. And the lighter grey is the solder paste cooking out the flux, and the flux is doing a lot of work here. It will be cleaning the circuit board, and if you see any smoke coming off anything, that is the flux basically evaporating. So what I'm going to do is I'm going to take the hot air gun, which you can probably hear going in the background. With this is set to about 370 degrees, and I'm going to turn it to its lowest speed, and then I'm going to start working my way around the board. Now, the first thing I'm going to do, I'm going to start by hovering. Now, I'm working round because what I'm trying to do is making sure I don't get too much heat build up in a very specific part of the board. And now I'm going to concentrate a little bit. Now, hopefully, you should see. Did you see that? It's sort of the solder changes color and goes shiny, and then a moment later, it grabs the component and sucks it into place. Yeah, don't get too upset about this smoke. It's not a problem. As long as you're not underneath a smoke detector. If you're underneath a smoke detector, I suggest you move. We've occasionally had to empty the college, call a call out the fire brigade. That's quite embarrassing. Also, you don't want to be breathing this. If you can do it somewhere which is ventilated, then that will be helpful to your health. Now, I would normally suggest using this wand directly from above because it makes it least likely that you'll blow components off the board. Unfortunately, there's a camera here, otherwise you wouldn't be able to see anything. And that camera gets in the way of me using this iron quite the way that I'd want to. Now, at this point, if you think, oh, I wish I'd centered that component a bit better, if the component doesn't move into place all by itself, then you can nudge it with a sharp knife or uh, a pair of tweezers, because you have those things available. And as long as the hot air gun still has it hot, these things should just move. And it's taken a very long time to get these capacitors soldered. And the capacitors, oh, there we go, suddenly it picks it up. Now that's because these capacitors are connected to some massive bits of copper. and those bits of copper suck the heat away. We're going to see that again over here probably. We'll see some legs solder pretty quickly, and some legs don't. But they will all go in the end. So we want to make sure that the whole device gets hot. Because remember, this has got a big thermal pad underneath it, and that big thermal pad really, really wants to be soldered. Because if it's not soldered, then the motors won't work properly, and they'll overheat. We don't like that. It shouldn't be dangerously overheated, but we still don't want it. We want our devices to behave correctly when they're out in the field. It's also quite difficult to test that is there when you bench test these things later on. So let's try and just make sure that we don't have that problem early on. Right, there we go. So you should be able to see that all those legs that were previously looked a little bit shorted out, they've all come good. The solder has disappeared between them, and they're nice and shiny. So finally, let's get this connector done. So the connector is suffering from the same thing as the rest of the board. Down at this end of the connector, there's a lot of things with massive copper planes, and it's taking a while for the heat to get into them. But when it does, it definitely wicks up around the legs of these connectors. But I didn't find a Google device named legs. I'm sorry, that was Alexa. She is in control of a lot of things in this place, but she's quite silly. All right. That leg doesn't quite look done. Down here, these ones clearly want a little bit of visiting. This one at the end is the 5-volt power. If we don't get that one done, nothing's going to work properly. The other ones, only bits of the component circuitry are going to mess up, but we really want to get the power rails done. So, to me, that looks good, but I warn you that I'm in pretty poor light here. So that all looks good to me. So the next stage is to let that all cool down, because at the moment it's going to be super hot. It's sat on top of a hot plate, which I've just turned off because we're only doing one board. It's sat on top of a hot plate, which is almost hot enough to keep the solder molten. So if we were to move the board now, we would probably have half the components fall off it because we've been heating that board super hot with a hot air gun. So just to remind you of those temperatures, the hot plate was set to 300 degrees and the hot air gun was set to 370 degrees. So I'm going to let that cool down. In order to help it cool down, what I'm going to do is shuffle it to the side. No, I'm not. I would shuffle it to the side, but I set the size of the jaws based on this circuit board when it was cold. So I've had to loosen them a bit, and now, no, still too tight. Let's try again. Yeah, there we go. I'm going to slide it over to the edge here. And this is what I suggest you do. Slide it out to about here, where it's hanging over the edge, but not likely to fall off the desk. And then you can fill this space with the next circuit board that you're doing, because I'm assuming that you're going to do a batch of these all together. So while that's cooling down, I'm going to switch off the camera. Okay, so we've switched view, and as you can see from the nice circle on the screen, we're viewing this one through a microscope. I've got quite a nice Swift stereoscopic microscope here. I highly recommend these for inspecting circuit boards because you can really see the depth of what's going on underneath the circuit, underneath the light, and the stereoscopicness really makes things jump out at you. It's very, very easy to inspect with this in a way which isn't so easy with the USB camera. So the USB microscopes, they're okay. They get you in round corners, but you don't ever get quite the same visibility that you get through one of these stereoscopic scopes. The ones designed for circuit boards move you quite a long way away from the desk, and this is a 10x. You wouldn't really want to go any larger than 10x because otherwise, well, the things you're looking at, you can see them really clearly, but you just can't see what else is going on the circuit board. So let's have a look at some of these components and see whether we think that they look nicely soldered. Now, these ones down here, you may be able to see a little bit of discoloration on this corner of the pad. And that is because the solder has wicked up the side of the pad and onto the actual device. That means that the solder is nice and cleanly on both sides of this connection, so we're good there. So we can say these little diodes, they look very nicely done. So that's cool. The next diodes across, these ones, this side, they look very obviously in this little cup. You can see the solder has just licked up the edge of the cup. So these ones are also, they're done reasonably well. This side, not so obvious. If I were to find that there was a problem with one of these LEDs, then I would come back with a soldering iron and I'd want to touch this side. That would be my first guess. I'd touch the other side as well because once you've got the soldering iron there, you might as well. But these look okay to me. Certainly, there's nothing that looks shorted. You might be worried about shorting down here. You don't need to be worried. All of these connections down this side are all the same connection. They all go directly to the 5-volt rail. So don't worry about anything shorted out over this side. It's only really this side that matters. And they all look good. So let's go up to the most lightly troublesome components, these tiny little resistor arrays. Now, I'm going to have to look through the microscope at this point because I can't really see on the USB clear enough. So apologies if everything goes a little bit swirly, but these look lovely. They each have a little fillet of solder around the bottom here, and there's nothing obviously shorted on any of these, so that's good. On to the ULN 2003. So again, the ULN 2003 looks okay. As we look across the bottom of these pads, bottom of these pads, you can see each one of them is wicked into the pad on the device, and if you run your sharp edge up there, you should definitely feel that that goes up on an edge. Again, you can see all across here they're sat in little pools which have wicked onto the bottom of the leg. If you come back with a soldering iron and you touch these, you'll probably find that pool will run over the top of the component and up the leg, but these are well soldered. There's nothing to worry about there. So let's go down and have a look at the shifter registers. The shifter registers are down here, the 74 HC595s. Again, they're all looking good to me. Across here, these pads are all nicely soldered. These ones are all nicely soldered. The capacitor at the end, looking good. Capacitor at this end, also looking good. You can see it's wicked up in this sort of concave shape. Concave is what you're looking for. If it's convex, you've probably got too much solder on there, but the solder at this point should be completely dictated by what went through the stencil. We've not done any rework here. If you were to rework it, then you may find that you've got more solder on these pads. It doesn't necessarily, convex doesn't necessarily mean a problem, but it does tend to hide problems which are underneath the surface. But these are all looking good. Oh, hang on. That one at the end. That doesn't look good to me. Oh, but it feels good. Okay, it's just the way it looks through the scope. Yeah, everything there's okay. Down here on this connector, yeah, looks okay. I'm never really sure that there's enough solder on these, but they kind of look okay. Now, when we're soldering these. This one here, that doesn't look properly wicked. So we're going to come back and we're going to revisit these with the soldering iron because, you know, you can't be too sure. And you don't want to mess up the connector. That's over here. You can see the little leg which exists inside this capacitor is well trapped within this solder blob on all of these capacitors, so that's all good. And this is definitely nicely soldered on both ends. Now this is our logic. Our logic looks nicely soldered. Yeah, all pins good. Capacitor's good. All pins on this one. Now this one, obviously, is not quite in the same place as this. You can see this one is shuffled over more to the edge. It's still completely on the pads. All the pads are nicely soldered. That's okay. If this was further across, I'd come back with a hot air gun and I'd just give it a nudge, move it back across. But this is okay. This is on the boundary of what is acceptable. This capacitor's good. Right, now looking down the motor controller, these pads, they're all good. We can just about see there's some solder that wicked out under here, which is what we expect to happen because that thermal pad is made up of solder and the solder will wick in both directions. Up this side, these all look good. This capacitor looks good. These capacitors look good. Down here, this capacitor looks good. These legs, they're all great. You can see the solder there filling the joint. These look all great. So this board, I would say, is a success. So the only thing that is going to worry me in any way at all is the legs on these. And I mean, I can now, with it rotated this way around, see the solder that is wicked around here. So I think that these are good, but because I am nervous about these things, I'm going to come back to the soldering iron anyway, and just put a little bit of solder onto those. So I'm just going to turn on the soldering iron and give it a little while to heat up. So if any of you have soldered before and you found it a pain to get solder to stick where you want, this is the magic. It's flux. So solder that comes in a roll like this stuff includes flux within it. When you put the solder onto the soldering iron, this flux will melt and it'll come off as smoke. That's the little smoke that you see coming off your soldering iron, and that means it's cleaning your soldering iron as it's doing that. It's a sort of acid, and it's cleaning away the tip of your soldering iron. And in a way, it's probably actually damaging the tip of your soldering iron because it is acid and it will eat the soldering iron very slowly. But when you apply it to a joint, it's also doing the same thing to the joint. It's cleaning away all of the corrosion and gunk that might be on that joint. And that's why you're advised, don't put solder on the soldering iron, put it on the joint. Because if you put it on the soldering iron, it all gets used up on the soldering iron before you get it anywhere near the joint that you're trying to make. Well, this is a pen, and it gets around that problem, because I can take the pen, I can take my circuit board, and I can just simply write it on. You can see it coming out there. I'm going to take it down all those connections. Now, it's not going to come out black. It's not a marker pen. It doesn't need any pressure. If you put pressure on it, you'll just ruin the tip. If you ruin the tip, well, you'll be sad. And you'll have to buy a new pen, even though it's full of flux. That's a bit wasteful. Slightly annoying for us guys as teachers who provide these parts for you. So now those bits are fluxed. If I go and visit them with a soldering iron, we should see the solder flow. Now, I'm not sure exactly how much solder is on this joint and whether you're going to be able to see this. No, not enough is the answer. So what I'm going to do is I'm going to clean the tip of my soldering iron off, and I'm going to come in and I'm going to add a little bit. So heating up the joint, and I'm adding the solder, and hopefully, yeah, there it goes. Right, 1, 2, 3, and off. And then we're going to go back, and we're going to do the next one. 2, 3, and off. Now, generally, when you're soldering, you want to heat the joint up nicely. The general rule is you want to be in contact no more than 4 seconds. But for a connector like this, you can be in contact for a lot longer than that, and it won't cause it any problems because, well, there's nothing intelligent in there to get cooked. The only thing that you can do to a connector is you can melt it. And this one will probably soften a little bit. It's got so many pins that as long as you're not pulling and prying the pins as you do it, it will survive. So I'm just going to go visit each of these. Now, as we go to these ones at this end, oops, you'll find it takes a lot longer to solder the ones at this end, and that's because they are well coupled into the circuit board. So you can see this big lump around J where it says J2 here. That's all a big connector. It comes up here, and goes into these pins. That's one of the motor controller outputs, and so it's very high current. And being very high current, there's a lot of it, a lot of copper, and the copper will suck away the heat. And if it's sucking away the heat, then obviously the solder's not going to melt very well. That may be what had happened earlier, but earlier we were heating it up on a heat pad, and the heat pad, of course, heated the whole of the connection, the whole of the connector, and both sides of the circuit board. That's what the heat pad's for. It's to prevent us getting too cool, or getting a differential between the bit that we're heating up and the things which are around it. So, hot air gun solves this problem nicely. Now I realise that I've fallen off camera because I'm trying to solder this with a USB camera in the way. But rest assured, what I'm doing is I'm going along this solder, this connector, getting a little bit of heat in, and then I'm sitting there for a while, just letting the heat soak into the pin, because we don't want a cold solder joint. A cold solder joint is where you heat up one side of the connection, add solder to it, but the other side doesn't have enough heat in it, so the solder doesn't melt onto it, and instead just sort of runs around it like a little jacket, but doesn't make a good electrical connection. So we want to avoid that because, well, it doesn't work. So I believe that I've done all that side of the connector. We're looking good now. The other side, you can see there are some connections I've done, some I've not done because they are difficult to do on camera. So what I'm going to do is I'm going to pause the camera, I'm going to solder those last few joints, and then I'm going to come back. Well, there you go. I was pretty happy with that. Those solder joints actually all look pretty good under the microscope. I thought I'd add a little bit more solder. Now it looks a bit messy. You see, those are those concave sort of bulges of solder that I warned you about earlier. Having done them underneath the microscope, I'm pretty certain that they're great. In fact, they looked fine until I pulled the soldering iron away and the solder that was wicking onto the soldering iron got sucked back onto the pad. So I'm pretty happy with them anyway. But this isn't really what they should look like. Now, if we get to a point where we have put too much solder on, then the easiest way to get it off is using this stuff. This is called solder wick. And solder wick, well, it's essentially just flattened copper wire with a little bit of flux on it. But because, it's sat in the toolbox for ages, the flux has probably dried out. So what I'm going to do is I'm going to use my lovely flux pen just to add more flux to it, just in case, just in case. So now I take my fluxed wick, I take my soldering iron. Now I warn you, whereas before I was talking about solder, now you can see just here it's running up the wick. If I pull it away, you see that the solder has come somewhat off this pad. Also, it's come somewhat off the soldering iron. Now I'm going to reheat this pad and make sure this pad is properly hot. Yeah, there it goes. Right. So that's how you use solder wick. You make sure that the wick itself is properly hot and pressed into the joint, and then you lift the two out together. If you don't lift them out together, then this big ribbon of copper will stay anchored to your circuit board and could potentially tear things off the circuit board, and you really don't want that. But the thing to remember about solder wick is, just like this area of circuit board below it is a massive heat sink of copper. So it does take quite a while for the solder wick to come up to temperature, and your soldering iron will be fighting that all the way. So put it on your joint, heat it up with soldering iron, and just sit there and wait. And eventually it will start wicking the solder away. When it does, you can then lift the two together away from your circuit board, and hopefully you'll be left with sufficiently less solder on your board that you can do whatever it is that you need to do, which might be taking components off, or it might be just cleaning up where pads have got bridged. Again, this board has gone a little bit too well, and so everything is fine. Hopefully, on the next board, we'll see where things go wrong, because we've got some much more fine pitch components, so we'll have to look at those in the next episode. Well, for the moment, good luck.